All right, this is a good example problem because this is something I would put on the test. 2.6, number 5. Find the slope of the tangent line to the parabola y equals x squared plus 2x at the point negative 3, 3. If you want to know the definitions, one of them is f of a plus h minus f of a over h, limit of, as h approaches 0. The other one is f of x plus delta x minus f of x over delta x, the limit as delta x goes to 0. They're the same. So let's just do one, okay? So let's just, we're going to change it. Oh, listen, it doesn't matter, and I guess I'll write this out so that everybody sees what I'm talking about. I want to be clear. Do we care which variables we put? Not really. I like f of a plus h, thus you've seen f of a plus h way more than x plus delta x, but we're not going to get in there, all right? So we're just going to go with 1, all right? So we're going to need this. I'm just going to get rid of the red, all right? And everybody, what it wants us to do, and you don't need to do this, Victoria, okay, is it wants us 0 and negative 2 are the answers, right? This is the parabola. It says at negative 3, 3, there's negative 3, 3 real roughly. They want us to actually give the equation of that purple line. They want the equation of the purple line. What do you need for equation for a line? You need slope and a point. Check mark on the point, right? So what we got to find is slope. Chapter 2, and now we've got a new name for it, but chapter 2 is we got to find the instantaneous rate of change at negative 3, 3. Or everybody, the easier way to say it, let's find the derivative. So let's just use the word derivative. So we're going to find this purple line. And I'm going to write it this way, everybody. And this might be one of the first times I've written that started off, right? F prime of A. The derivative of A is going to be determined by this equation. When I plug it in, I get a plus h squared plus 2 times a plus h minus, and I'll put parentheses around my f of a so I make sure I distribute the negative, one of the common errors, right, over h. You make Miss Davis square out the binomial or not? Nah, let's not. I know she can. All right. Everybody, we square out the binomial. A plus h times a plus h is a squared plus 2ah plus h squared. We'll rewrite that down below a little prettier. All right. So we end up, and what has to happen? Everybody, what has to happen now? We have to get rid of everything but the h's, right? All the terms have to disappear but the h's. And if they didn't, what does that mean? It means you've made a math mistake. Because we all agree that a parabola polynomial is a function. And it happens, right? The bigger and uglier they get, the more often we make math mistakes. Mr. Anderson looks. H in this term, H in this term, H in that term. All right. How comfortable are we getting? Are we ready to cancel an H and put the 0 in at the same time? In blue, canceling the H does this. All right, and it leaves you with 2a plus h, 2a plus h plus 2. And let's take the h to 0. So I get f prime of a equals 2a plus 2. And everybody, as we get better and better at this, I'll go to an entire page. We cannot be surprised that 2x has a slope of 2. Right? Limit laws, we know this. And we're not probably surprised, we've done so many of these, we're probably not surprised that the derivative of x squared is 2a. We probably still are struggling with why that happens. That's the next big step for us, all right? Yeah, after the test. So everybody, I want to know at negative 3, that's the a value, do you agree? So you plug in f prime of negative 3, negative 6 plus, I get negative 4. So find the equation in part A. All right, slope is negative 4. point is negative 3, 3. Everybody, especially point slope form, right? This is what we got to get good at. Y minus 3 equals negative 4 times x minus a minus 3, which is x plus 3. And don't go any further. That is the equation of a tangent line. Don't solve for y. Don't do y equals mx plus b. Just stop. Unless I told you to solve for y. Unless it says find the equation of a tangent line, y equals f of x. Then the only problem with this problem is what's with y? Negative 3. So you just send the negative 3 back into the other side. That's y equals. Oh, graph the parabola. Graph the parabola. As a check on your work, zoom in toward the point until the parabola and tangent are indistinguishable. I had that graph and I erased it. So, darn. All right, so let's try that. We use 0 and negative 2. There's a graph. And I suppose if I draw a real line, I'm a real boy. All right, does that look like a real line? Let's see how well we did. So, and it hits here, so we got to take a guess. 1, 2, 3. Whoop. You know, that looks about like negative 4. You know, run a 1. I mean, if I'm finding the 2 value here on the red line, run a 1, rise a negative 4 there. And it said zoom in until it was indistinguishable. We blow that up, 300%. What they want you to see, and I can't get tight enough, but do you see how for a little bit here, the blue line and the black line literally disappear? One line, right? And this is the key. Listen, we don't do this for parabolas, everybody, because we know what the parabola is going to do next. Does everybody agree? But what we can do is, if we don't know what the next step is, we estimate the next step based on that line. Does that make sense? Take the best guess. All right. You said squeeze, sandwich, squeeze there, squeeze there. You calling it a sandwich because you like that. A squeeze theorem. Let's say we're going to take the limit. Whoa. The limit as x approaches 0 of x to the 6 cosine 1 over x equals 0. We're going to prove this. We're going to prove this, all right? So that would be the instructions. Prove. All right, let's record this. Oh, I'm still recording.